Okay, let's continue with another example of projectile problem. Okay, you read the problem, the question. Example number 9, for being on the chipping machine. So I believe some of you never seen what is the chipping machine. Chipping machine basically is a machine that you break wooden stuff into powder or chips, wooden chips, right? Or you want to get away all the chopped leaf and all this. You use this machine. So you have a chipping machine designed to eject wood chips at velocity 7.5 meter per second. If the tube oriented at 30 degree from the horizontal, determine how high the edge of and the chip strike the pile if in this distance they land on the pile of 6 meter from the tube. Okay, so let me show you one by one. And if you are downloading the tutorial question, you're going to get the diagram instantly. All right. So this is the chipping machine, like what you see over here. So when you chip, the chip will fly from the mouth over here, and you can control the angle where you want to the output. You can control the angle. So this one is pointing down, but in this tutorial question, it was oriented 30 degree from the horizon, means this one was 30 degree going up, meaning there will be a projectile free motion of the chip fly over the air and drop over here. Okay, so this one will go 30 degree in the air, and because of the gravity pointing down, it will land over here. Okay, so we take the origin over here, the end position over here, and the distance, horizontal distance from the origin to the last position will be 6 meter, as you read from here. Okay. And if you draw a horizontal line from the mouth there, from the mouth of the chipping machine, you draw a line to represent the origin from the mouth, and you label it X from the origin. So anything below this position will be negative. Again, anything that below this line or Y position, anything that below this point going down, your Y will be negative. Your X always positive to the right. So only you need to worry is the Y position from the origin. If it's going down, it becomes negative. Just take note on that. Okay. So I just draw a line, horizontal line over here, just to show you that this is the ground horizontal to the wheel, just to make sure that we can measure the height compared to the origin. Then I put in the y-axis over there, origin. At here I put 0 just to illustrate, right? And again in test, I might change this O become A like the question previously. So you need to synchronize your answer according to the diagram. This one, because you're seeing O, you can use O in your answer. The question asks you about this H. Okay? The question asks you about this H. Okay. All right. And the position is 1.5. Does it mention here? Oh, so it's not mentioned here. So this is the additional information where from the ground to the mouth will be 1.2 meter. Meaning you need to find this gap. Okay, you need to find this gap. He asks you determine the height of H the chip strike the pile. If any instant they land on the pile 6 meters away from the tube. You imagine, this one, you shoot from 30 degree and it strike over here, right? You go up 30 degree and it strike here. I draw the point A just to show that this point A is horizontal to the mouth of your output. And I draw the velocity shoot up, your original velocity with the angle. Velocity, usually I use green color for velocity, but red color for acceleration. But in this example, I use velocity as red color, just to mention that one. And there will be like one path for the chips to fly. Okay, at 30 degree over here, 30 degree. Okay. So your VO is 7.5, and you know that all the vector you can break into x-axis and y-axis. It will be good you break this one before you solve the problem. So from the question, once you see there's a vector that have an angle, the first step I will recommend you quickly expand this one to y and x-axis using trigonometry or tangent relationship. Okay, you have 30 degree, you can relate this one to horizontal and vertical. Okay, the pile will hit there. You need to find the H over here. Okay, so I remove some of the statement there. I just put in the objective of our question. So you start from origin and V naught. You start from here with the velocity, this one. Is there any information? So you expand. This one you expand to x, you get VOX or VXO, same. And you expand to y-axis, you get VOY or VYO, same. Okay. So VOX, this component, you use tangent or you can use cos. Once you have the theta, you use vertical and hypotenuse, the side and hypotenuse. You use cos relationship. Right, this one and this one is a cos. So cos 30 equal to the side and this one, right? So you rewrite the trigonometry equation. VOX equal to V naught or V0 cos 30. You get this component. You do the same for VOY, but you use sine because sine is opposite divided by hypotenuse. Okay. You use sine 30 to get your y-axis. So VOY, you get another value, 3 point something, 6 point something for x. Any questions so far for x component and y component?
So far, no, sir.
Okay, good. Stop me if you see something very weird to you. Don't keep quiet. All right. You keep quiet. I assume you understand. Okay. Then I just to remind myself the direction. Blue color to the right positive. Blue color going up is positive. So my VOY is going up with positive value. My VOX going to the right with positive value. Okay, so far you have to understand the direction. And again, velocity is a vector. Vector have magnitude and direction. The equation just now, VAX equal to VOX. Okay, this one from the relationship that we learned just now. All right, the sixth equation, you have 3 for the vertical, 3 for the horizontal. On the horizontal, you know, right, the n velocity is the same. no matter where it go, right? This starting velocity, x component will same as the n x component. So you can write this one, Vax equal to Vox. So you have this component. So direction also to the right. So this, each one give you, this one 1 mark, this one answer 1 mark. So 2 mark, 2 mark, 2 mark, 6 mark already for this answer. For vertical, for horizontal, not for horizontal, for your OX and OY and also your AX, VAX. Again, just remind yourself, A pointing down. Again, in exam, you forget to draw this one also, no problem. It just will help you to remind yourself that there is a vertical direction. Okay, and it's a negative sign there, negative 9.81 for your A. So I put all the information there. Just now we already calculated what is our AY. AY don't need calculate now. It's a standard. You have your VOX 6.5. You have your VOY is 3.7 something. Okay, next. Okay, VAX is this one, 6.5. Okay. You know that the velocity here is 6.5. Next, we look into horizontal and vertical in more detail. So just now we derived the magnitude of our V, and at the same time, you can relate the x component of the velocity in the Newton, or you can derive these two equation, these two relationship in this section also, no problem. Okay, again, you can break your answer sheet into two half, one horizontal, one vertical. Horizontal, all the positive direction is to the right. Vertical motion going up is positive. Recall the three equations that I mentioned just now, or you already derived earlier, and you compare side by side with the diagram, solve for horizontal motion. First one, because I choose the second one because I know my x direction. I know my x direction. That's why I jump to the first one. Also, you already solved already, actually. The first one you already solved just now. I go to the second one, x equal to XOVOXT. X, the first x is the n location of your A. You know that at this point is 6 meters from the origin. Okay, XO from here is 0. Velocity of your VXO you define. T you continue to calculate. So you modify accordingly the second equation into this one. Remember to synchronize your answer with the diagram. So XA over here, XA here means the X direction from the origin is 6 meters. XO, origin, VOX already defined. TOA means time from O to A, or you can just put T, never mind. Okay, so you substitute all the answer there. 6 meters, XA over here is 6 meters from the origin in X direction, horizontal motion. XO origin 0, you start from 0, 0. VOX already defined just now, 6.5, substitute here. You only left out one unknown in the equation. Quickly go and solve the T to travel from this point to the location of A. You use a calculator, you find your T equal to 0.923 seconds. Okay, up to here. Once we find our T, we move to the next slide. Okay, you cross-check with the three equations just now. Is there any equation you haven't solved? If you haven't solved, you go and solve it. If you already solved, you move to the next one. Right? You refer to the three equations for vertical, three equations for the horizontal. So you compare side by side equation. Once all the equation you solve already, you move to the next one. For vertical motion, okay, I move my answer just now. For vertical motion, you see, okay, recall the answer over here, I put over here. So these are the three equations that related to vertical motion. Okay, modified accordingly. So I choose the second one is because I know my height. Okay, so I choose the second one. I put it there. I modify accordingly. This is the last location of your y. So I put YA here. This is the YA equal to the origin of y, this one. In this case, I can use 0 because in the diagram I use 0. Okay, so this one, VOYT, continue copy. This one, copy half GT square, copy, yeah. T, you can either use back the T or you can just, you can denote more specifically what is that. Okay, you use T, only T, no problem. Huh? Then you put in all the answer over here. Okay, let me explain. What is YA? What is YA? YA is the H. How you find the gap over here? You take 1.2 minus H, right? How you get Y location? How you get the Y location? You take, or either you can take the Y.2 minus H, or you can take H minus 1.2, no problem. Because we don't know either the H is bigger than the A location or is lower. We never know. Okay, so this diagram is just an early estimation. And if you compare side by side this calculation, in the calculation we assume the H is higher than 1.2. Okay, yeah? In this case, we assume the H here is higher than 1.2. That's why we put H minus 1.2. If you assume H is lower than 1.2, then you remember you need to put some note here. H is lower than 1.2. Assume H is lower than 1.2. Then your answer, you'll get positive or negative. Then you compare to the answer. In this case, we assume the H is higher than 1.2. We assume. That's why in this answer, I put H minus 1.2 because I assume this H is higher than 1.2. Y 0, 0, because we start from origin, the Y is 0. VOY you define just now. VOY is 3 point something. You substitute here. What else? VO. T you define just now. T at this point you define already. 0.9 something. You substitute inside here. Half you copy. Gravity copy. Not copy, but you know the answer. Standard. Negative 9.81. Okay. And your time also known. 0.9 square. Yeah. You solve this equation. You'll get H equal to 0.483 meter. Means your H is 0.43 meter here. Okay. You can also use this equation to solve the question. All right. So this one is only one of the way to solve. You have 6 equations or 3 equations for vertical to solve. I choose one to solve. Okay. Okay. So this is how we solve for example number 9. Let me end the recording. Any questions so far? Let me end the recording.